Hello dear students, welcome to Tejuma YouTube channel. In this video, I am going to discuss about new topic in KCET 2027 series. This topic name is electric potential from the chapter electric potential and capacitance. Okay, so let us discuss about what is electric potential, potential difference, and we'll solve some questions based on it also. See, electric potential is defined as the amount of work done. We define electric potential in terms of amount of work done in moving a unit positive charge from infinity to given point, okay, against the electric force created by a source charge. So that work done gives you the electric potential at a given point. Let's consider here this point R is at infinity. So we can consider electric potential at infinity is 0. So we're bringing a charge, this small charge that is Q. This is a moving charge called the test charge. We are bringing this charge from infinity to point P against the electric field produced by capital Q. So we are going to find the potential of capital Q, electrostatic potential of capital Q at P. So here electric potential is P. Okay, this work done to move the charge from here to here is called electric potential. So mathematically we write W divided by Q. But this work done, the work done to move the charge, is done without changing the velocity of the charged particle, and the acceleration should be 0. That means along with that the velocity also should be very less. Okay, we should not change its kinetic energy, because if we change the kinetic energy, what happens? You may have to consider the change in kinetic energy also. But here we are defining the potential and potential difference. We have to move the charge very slowly. The moment of test charge should be very slow. That's why without any acceleration or change in kinetic energy. Clear? So then mathematically it can be given by W by Q naught. What is the unit for electric potential? So here for work done it is joule, and for charge it is coulomb. So joule per coulomb is the unit of electric potential here, or the common unit, that is volt. You can use volt also. Clear? Then we have electric potential difference. So instead of considering from infinity to given point, what if we move the charge from point A to point B? The amount of work done in moving a charge from point A to point B, or from point B to point A, whichever you want, you can take. The amount of work done to move the charge from A to B, okay, against the electric field produced by the source charge, that is capital Q, gives the electric potential difference between these two. So mathematically it is given by final potential minus initial potential, which is equal to work done to move the charge from initial point to final point divided by the moving charge, that is small q. This gives the electric potential difference. Here we are moving it from A to B, so we can write final potential is B minus initial potential is A, that is VB minus VA, is equal to the charge is moved from A to B divided by the moving charge is Q, or you can consider it as Q naught also. This is electric potential difference. Okay, so by using this, can we define 1 volt? Yes. So 1 volt can be defined by W by Q. Let us take 1 joule of work is done to move a charge of 1 coulomb from one point to another point. There the potential difference will be 1 volt. The potential at a point is 1 volt, or the potential difference is 1 volt if 1 joule of work is done to move a charge from one point to another point, or you can take from infinity to a given point. Clear? That is about 1 volt. Then what is the expression for electric potential due to point charge? Due to point charge, electric potential is given by 1 by 4 pi epsilon Q by R, where the value of 1 divided by 4 pi epsilon naught is given by 9 into 10 to the power 9 in SI unit, in SS system. But in CJS unit, value of 1 by 4 pi epsilon naught is 1. Where? In CGS unit. Clear? Then we have principle of superposition of electric potential. Due to group of charges, potential at a point in the electric field is V1 plus V2 plus V3. So on up to Vn you can consider. Let's consider here we have a charge 1, that is Q1, charge Q2, charge Q3. Maybe it is positive or negative, whichever you want you can take. What is the electric potential at this point? So due to positive Q1, the electric potential here is V1. Due to Q2, electric potential is V2. Due to Q3, electric potential is V3. So we can keep on adding it for n number of charges. This is called principle of superposition. Okay, the net potential at the given point is given by potentials due to sum of potentials due to all the charges. Clear? Moving on to next one. This is very important. Electric potential due to dipole. What is a dipole? Two equal and opposite charges separated by a small distance. So at any random point around the dipole, what is the electric potential? For theory concept, you must have studied this and you must have derived this, that is electric potential due to dipole, that is given by 1 by 4 pi epsilon naught p cos theta divided by r square minus a square cos square theta, where if r value is so much greater than a, we can just write this much. Okay, that is V is equal to 1 by 4 pi epsilon p cos theta by r square, where p is dipole moment. Dipole moment. And r is the distance of the point from the dipole, and cos theta is there 1 by 4 pi epsilon naught value, you know. If in case, if you consider the point along the axis, so if this is the dipole here, it is given along the axis on either side, if you consider, so theta value will be 0, so cos 0 is 1, you will get this. But along the equatorial, let's consider this is plus, this is minus. Okay, so along the equatorial, any point in that plane, okay, let me consider. In this plane, at any point, so the electric potential will be 0. Okay, because theta will be 90 degree, so cos 90 is 0. In this particular plane, equatorial plane, the electric potential will be 0, because due to positive charge and due to negative charge, electric potentials get added up, means they get cancelled when they added. Okay, because one is positive polarity, one is negative polarity, the potential will be 0 in the equatorial plane. Clear? So based on this, we have few questions. Let us solve them one by one. What is the electric potential at a distance 9 centimeter from a point charge? So we know the formula, that is V is equal to 1 over 4 pi epsilon naught Q divided by R. In short, if dielectric medium is not considered, we can write KQ by R. K value is 9 into 10 to the power 9. So charge is 1 microcoulomb, means 10 to the power minus 6, divided by R is 9 into 10 to the power minus 2. So here 9 get cancelled, that is equal to 10 to the power 9 minus 6 plus 2 is equal to 10 to the power 5. So volt or joule per coulomb, that is option B is correct. Moving on to the next question. 2 point charges 2 microcoulomb and minus 2 microcoulomb are placed 10 centimeter apart. So we can consider it as a dipole, 2 minus 2, separated by 10 centimeter apart. The potential at the midpoint. So midpoint comes along the equatorial plane only, so the potential will be 0. Just now we have discussed. Along the equatorial, potential will be 0. Or you can consider at equal distances and opposite polarity charges are there, potential will be 0. Then the potential difference between two plates is 10 volts. Okay, there are two plates, potential difference is 10 volt. Work done in moving a electron between them is, so work done to move the charge in potential difference is given by Q into V. Okay, this can be equated to kinetic energy also, where what is the charge? Since it is an electron, you can take its magnitude as 1.6 into 10 to the power minus 19 into, what about the volt? 10. So that will be 1.6 into 10 to the power minus 18 joules. So option B is correct. Next, moving on to the next question. The potential difference between two parallel plates is 10 centimeter. Oh, sorry. Potential difference between two parallel plates which are 10 centimeter apart is V. Okay, distance between the plates is 10 centimeter. So potential difference is V volt. The potential difference between the two plates which are having the distance, let's consider this is D1, D2 is equal to 4 centimeter is. So potential difference is how much? D1, D2. Okay, since we can consider potential difference is uh, inversely proportional to R, so we can take V1 by V2 is equal to D2 by D1. Okay, so V1 is V divided by V2 is V dash, or V2 you can consider, which is equal to D2 is 4 divided by D1 is 10 centimeter. So that will be, how much is this? Yeah, so V2 is equal to 10 divided by 4 into V, that is 0.4 volt. That is option B is correct. V2 or V square, it's not V square, it is V2. Next, the work done in moving a charge 3 coulomb through a potential difference of 6 volts. Same work done is equal to charge into volt. So charge is 3 into potential difference is 6. 6 3s are 18 joules. Option C is correct. The electric potential at an equatorial point of dipole is, equatorial point means equatorial plane, electric potential will be 0 for the dipole. For a short dipole, the potential V at a distance r varies as, it is V is equal to 1 over 4 pi epsilon naught p cos theta divided by r square. In short, we can write 1 by 4 pi epsilon as k p cos theta divided by r square. So V is inversely proportional to r square. Therefore, option B is correct. Next, the potential at an axial point at a distance r from the short dipole of dipole moment P is, axial point again. So V is equal to K P cos theta divided by r square. For axial point, cos theta value will be 1. So Kp by r square. So which option is correct? Option B. Next, if the potential at a distance r on the axis of dipole is V, potential at a distance 2r on the same axis is, since potential is inversely proportional to r square, so V dash will be equal to V divided by r square, means here 2r is given, 2r square is 4r. Okay, so it will be V by 4. Is it for dipole? The potential at a distance r, yeah, dipole is given, r square will be there. So 4 V by 4. So electric field and electric potential of an electric dipole varies with distance as, electric field is inversely proportional to r cube and dipole it is r square. So r cube and r square where it is given, none of the options are correct, because let me consider this is r square. So option 2, because for potential it is r square. So I'll change the option B as r square. Okay. Then in the figure given, so much of theory is given. So I'm just asking you directly, at A, B, C, what will the potentials? So potential at A will be equal to potential at B. So in option 1 it is there, option 2 it's not there, option 3 and option 4. But in the direction, do remember, in the direction of electric field, in the direction of electric field, potential, electric potential decreases. Okay, potential decreases. So at VC, at C, potential will be less. So option D is correct. So at potential A and potential B, they are in the what is that? We can consider as equipotential surface. They are on the equipotential surface. So potential will be same. So VA is equal to VB, and at C potential will be less. So which is greater than VC. Option 4 is correct. So here also they're asking the potential is minimum at, just by looking at the diagram you can write. So there are 4 points are given, electric field is given. So potential A, potential B, potential C, potential at D. So minimum will be at A, because in the direction of what is that electric field, potential decreases. B and D same potential will be there. C will be maximum because its starting points. At A potential will be less. They're asking you to write mention at which point potential is minimum. So option A is correct. So here also the direction of electric field is given. So how do you relate potential at A, potential B and potential C? So here you can say potential at A will be greater than potential at B, because in the direction of electric field potential decreases. So sorry, in the direction of potential decreases, no, VB is greater than VA. So VB value will be greater than VA value, and that will be greater than VC value. Okay, so now VB is greater than VC. Where do I have VA is equal to VB? Wrong. VC is greater than, no, wrong. In the direction of electric field potential decreases. None of the options are correct. So let me write one more option where greatest will be at B, and then which will be greater than VA, which will be greater than VC. So electric field means it will be more at A and B, it will be same, but electric potential will be more at B because it is in the direction, in the beginning itself it is there. Clear? Next. The charges, each equal to capital Q, are placed at the corners of a hexagon. So hexagon of side A. So let me consider a hexagon here. So this is hexagon, regular hexagon. Okay. At each corner charge is placed. How much? Q, 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 this one. Okay. Now what is the electric field, electric potential at the center? Since the side given is A, what will be the distance? This distance also will be A, because this forms a equilateral triangle, all sides will be same. So all these distances from the charges will be same. So charges are same, distance is same. A, 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 A. So potential due to all the charges is 6 into KQ by A. 6 into KQ by A. That is 1 by 4% 6 Q by A. Option B is correct. Next. we have board level questions for 5 mark. So if you understand this, this will help you for your competitive exams also. That's why I have given this here. Two charges 30 nanocoulomb and minus 20 nanocoulomb are located 50 centimeter apart. At what point on the line joining the two charges is the electric potential is 0? Take the potential at infinity is 0. Okay, so we need to consider two charges along the line. Let's consider here we have a charge q1 is equal to 30 nanocoulomb and q2 is equal to minus 20 nanocoulomb. They are separated by some distance r. Okay, so r is equal to 15 centimeter. 15 into 10 to the power minus 2 meter. So here we have a point. We need to find out the point where electric potential is 0. Let me consider this point is at a distance x from q1. You can take from q2 also, but here I am taking from x. X is from q1. So potential at O is 0 because potential due to first charge plus potential due to second charge summing or adding up to 0. So can I write V1 is equal to minus V2? Okay, what is V1? Let me write it neatly. Okay, V1 is equal to minus V2. What is V1? K Q1 by X minus what is V2? K Q2 by R minus X. No, this distance will be R minus X because total distance is X. Okay. So KK get cancelled. Q1 is 30 nanocoulomb divided by X, which is equal to minus Q2 is also minus get cancelled, minus 20 nanocoulomb divided by R minus X. So minus get cancelled, 0 nanocoulomb, 0 nanocoulomb. So 3 divided by X is equal to 2 divided by R minus X. So that is, we can multiply 3R minus 3X is equal to 2X. So therefore 5X. Okay, 5X is equal to 3R. X is equal to 3 by 5R. So X is equal to 3 divided by 5 into R is 15 centimeter. X is equal to 5. 5 3 is a 3 3 is a 9. 5 1 is a 5 3 is a 3 3 is a 9 centimeter. So that is 9 into 10 to the power minus 2 meter or 0.09 meter. Okay, this is the answer for this question. Moving on to next one. Charges 2 millicoulomb, 4 millicoulomb and 6 millicoulomb are placed at the corners of ABC of square of side x meter. Find what must be the find what charge must be placed at the fourth corner so that the net potential at the center will be 0. So for this I need to draw a square. Let me minimize this. Okay, let me draw a square. So consider it is not the perfect square. Okay, so this is the diagonal. Okay, so this is the square. Let's consider. So 3 charges are placed at A, B, C. This is A, B, C. What is the charge placed at A? That is 2 millicoulomb. B, 4 millicoulomb. and at C 6 millicoulomb. Since I'm teaching it for KCET, so I'm not substituting the value of milli and all. But actually for boards you have to write the data in SI unit only. What is the charge must be placed at D? Let me consider it as QD. What is QD? So that the net potential at O will be 0. That is potential due to charge at A plus potential due to second charge at B, potential due to third charge at C, and potential due to fourth charge at D will become 0. So we know that VA is given by, so what is the side given? X, no? What is the half of the diagonal of this square? X by root 2. Total diagonal is root 2x. This length is x by root 2. So K QA by x by root 2 plus K QB by x by root 2 plus K QC by x by root 2 and QD K divided by x by root 2 is equal to 0. Clear? Now K divided by x into root 2 will go to the right side, so it becomes 0. You can take common and multiply it to the right hand side. Since right hand side we have 0, it will become 0. Then we'll be having QA plus QB plus QC plus QD is equal to 0. So QD is equal to minus QA, QB and QC minus, what is QA? 2 millicoulomb, QB 4 millicoulomb, QC 6 millicoulomb. So 6 plus 4 is 10 plus 12. So minus 12 millicoulomb is the required charge. That is how we have to solve this. This question was asked 3 times in final examination for PU board in Karnataka. Next, we have question based on work done. I will give you hints. You try to solve it. Okay. Here we need to have a square. ABCD is a square of side 2 meter. Let me write a square. Okay. This is a square, and let me take the diagonal in this direction. Diagonal is given by root 2x. If side is x, that is given by 2 meters. So this is root 2x means root 2 or 2 root 2 will be the diagonal. So here we have charges placed, that is at A, B, C. Okay, so at A we have a charge that is 5 nanocoulomb. So at B we have 10 nanocoulomb. Then we have minus 5 nanocoulomb. Okay, we are moving. So what is the work done in transferring a charge of 5 millicoulomb? So Q naught is the charge which we are moving. From where to where? From D of the fourth vertex of the square to the point of intersection of diagonals. So from point D to point O, we are sending the charge. So what is the work done for this? So work done to move the charge from D to O is given by final potential at O minus initial potential at D into the moving charge, that is Q naught or QD also you can consider. So we need to find out the electric potential at O. Let me find it. I'll give you the formula for that. So electric potential at O is given by electric potential at O due to charge A plus electric potential at O due to charge B plus electric potential at O due to charge C is equal to K divided by distance will be same. For all of them from A, B, C, distance is same. That is 2 root 2 divided by 2 is root 2. Root 2 will be the same. So just substitute QA value plus QB value plus QC value. So QA and QC are opposite, 5 minus 5 get cancelled. Only you have to substitute QB value. K value is 9 into 10 to the power 9. Correct, no? Now, what is potential at D? Here distance will vary because of B charge. But for A and C, the distance will be same, charge is same, they get cancelled. Potential at D due to A plus potential at D due to B plus potential at D due to C will be given by K into QA by distance is 2, 2 will take common, okay, plus QB divided by 2 root 2 I have taken common, okay, plus QC by 2 I have taken common. You just substitute the value of QA, QB, QC, you will get the answer. So these two if you substitute here along with Q naught, you will get the answer. So try solve it, consider it as homework. Whatever, wherever you want to solve, you can solve it. Find the answer, and if you find the answer, please text in the comment section. Okay, so here also the same thing. A charge of 8 millicoulomb is located at the origin. Calculate the work done in transferring or in taking a charge of minus 2 into minus 8 coulomb from point A to point B via point C. Let me discuss about this. A charge of 8 millicoulomb is placed at the location, that is origin. Let me consider. This is y-axis. This is x-axis. Okay. So there is a charge at the origin, 8 millicoulomb. So let's consider this is the source charge, 8 millicoulomb. Then what is the work done to move the charge, small charge? Moving charge I'll consider it as Q naught, that is minus 2 into 10 to the power minus 8 coulomb is moved from point A, that is on x-axis. So that is 3 centimeter to point B, that is on y-axis. So 4 centimeter. Okay, via point C. Point C is not required because so work done here is independent of the path, so you can directly take this path. So via whatever the point it is going, doesn't matter. So according to what is this? We have a Pythagoras theorem. If this is 4, this is 5, the hypotenuse side will be 5. If you want to calculate this distance, AB will be equal to how much? 5 centimeter. If it is required, you can utilize it. So what is the work done? Work done is given by final potential at B minus initial potential at A into moving charge. Okay, so let us find out VA and VB. VB is KQ by this. Let's consider this origin is O, OB, K capital Q by OB. K is 9 into 10 to the power 9. Capital Q is 8 millicoulomb divided by distance is 4 centimeter. So 4 1s are 4 2s are 9 2s are 18. 10 to the power 9 minus 3 is 6 plus 2 8 volt. Correct? 4 2s are 8. Matter 9 minus 3 is 6 7 8. Okay, this is the potential at B. Potential at A is KQ by OA, that is 9 into 10 to the power 9 into charge is 8 into 10 to the power minus 3 divided by distance is 3 into 10 to the power minus 2. 3 3 is 9 and 24 24 into 10 to the power 8 volts. Okay, so we have found potential at VA and at B and A. So that is equal to 18 into 10 to the power 8 minus 24 into 10 to the power 8. This is 18. Okay, 18 into Q naught is minus 2 into 10 to the power minus 8. So that is equal to 24 minus 8 is 6 minus 6. Okay, into 10 to the power 8 into minus 2 into 10 to the power minus 8. Since negative sign is there, I'll put this in bracket. Minus minus get cancelled. 6 2 is 12. 10 to the power minus 8 plus 8 get cancelled. So 12 joules will be the answer. This is also board level question. Okay. So this is about this topic, that is electric potential and electric potential due to dipole, point charge, and the potential difference we have learned. Okay, so electric potential is given by W by Q. Potential due to point charge is KQ by R, and potential due to dipole is K into P cos theta divided by R square. So based on this, we have solved questions today. Next class, I will be discussing about what is that? You can consider torque acting on a dipole and potential energy, and what is potential energy. Then we have what is that, concepts like dielectric materials we have, and we have some numericals also. We'll try to solve them in the next video. So if you feel the content is useful, please share it to your friends. We'll meet you in the next video. Till then, take care. Bye bye. Thank you.